So last time we covered this thing, and I did example also. So you have this thing in the video. Um so we are saying that if you have a, so this is basically what we did. This is summary of all those steps what we did last time. That if necessary, a unique start state without incoming edges and unique final state without outgoing edges. And for each state that is not a start state or a final state, repeat steps 2 and 3. So bypass operation, remove the states, eliminate the edges, remove the loops, and combine edges, combine loops, and remove the states. And finally, you will have just one start state, one final state, and that the label of that edge will be the regular expression of that TG. So this is what we did last time. This is the summary of that. If you guys have no questions, so that's good. You need more practice for that. This is something very important. And now, every language that can be defined by a regular expression can also be defined by FA. So it means that if you have a language and if it has a regular expression, we can convert that into an FA, and we already saw that. And now, by constructive algorithm, if you want to write the recursive definition of that for the regular expression, so we can say that there is an FA that accepts only the empty word lambda and the FA that accepts only a single letter. If there is an FA that accepts a language defined by R1, so the first condition is that you have an FA, and if you have a language and this language is not a file language, it only accepts a single word, and that is lambda, which is not which is a word without any letter. So still it is an FA. So it is a valid FA. And then we are saying that if you have if there is an FA and this FA defined by regular expression 1, and then there is another FA and it is defined by another regular expression 2. And if you combine these two FAs, you concatenate these two FAs, R1 plus R2. The resultant thing will also be a regular expression. And um, this new and the new thing which you create, it will also be an FA. It will not change its behavior. So it's very easy. We can say that if you have a language, how do I write this? If you have a language and you have FA one for that language, and the regular expression is R1, and you have another language, and this is a regular language, and you have FA2 for that, and this is it can be represented by another regular expression R2. If you combine these two regular expressions, this can be represented by another FA, and this will be a regular language. So it is possible that the job which is done by two machines, you combine them and make one machine, and one machine can do both jobs, the job of machine 1 and the job of machine 2. And it will not change the behavior of the language. It will still remain the regular language. And it can be represented by R1 plus R2. So what R1 plus R2 means, that this is a language, it's a new language. It can accept all words which are represented or valid by language 1, FA1, R1, or it can accept, it can validate, it can pass all words which are accepted by language 2, represented by FA2, R2. Now you combine these two machines and it is working as a one machine. So order does not matter here. It can either accept a word from R2 or R1 or R1 or R2. It will not accept a word which is combined word like, but it will accept all those. So it's a union set, you can say, of language 1 and language 2, R1 or R2. Okay. So this is equal to this thing is equal to union of FA1 and FA2, or you can say R1 union R2. So this is equal to this thing. Okay. So R1 plus R2. It is a union. So any question here, guys? No question? Okay. So if there's no question, so then so you understand this thing, it means, okay? Now we are saying that I cover this line and now this was which I explain is this. And now it says if you have an FA and it is represented by FA1 and this FA1 is represented by regular expression 1 and you have another language which is a different language. It's a regular language but it is completely so this FA1 and R1 represented a language which is a regular language and then you have another language which is another regular language and it can be represented by FA2 and it can be represented by regular expression 2. You can combine these two FAs by concatenating them by R1 dot R2. So this is different from R1 plus R2. In this case, so now what does it mean? It means that you are concatenating FA1 dot FA2. Okay. So here, this thing is basically, it means that you create a new, and it can be represented by a new machine, FA3, and it is a new regular expression R3. Okay. So here, what you are saying, I want to create a new machine which will do job of these two machines R1, R2. Here we are similar what we did before, but now order matters. So you want to create a new machine which will accept a word. That word always start from those words which are accepted by R1 and always end with those words which are ended with R2. Means so uh, uh, so what the if you see a word, let's say something like that, a so let's say R1 generate all words which belongs to A, which has just A's, and R2 generates all words which are just B's. So then this machine will be A, and B. So if you see that the start of the word will be from the R1 and end of the word will be B. You will never see A because order matters here. So this is called a dot product of your two regular expressions. But the beauty is when you apply the dot product instead of concatenation, it will still does not change the behavior of the language. It will still remain the same language, the regular language. It will be a new, it will create a new language, but that language will not change or its scope or its behavior. It will still be a regular language, but a new language. And you can represent that, and that the resultant thing will be a regular expression, but it's a new regular expression, and this will be represented by fa3 and r3. So same is case here. So in this case, which is statement number two, so now statement number two, order does not matter here. Statement number three, order matters here. R1 dot R2 is not equal to R2 dot R1, whereas R1 plus R2 is equal to R2 plus R1. Okay, so this is case here. So here order matters here. So now Fourth step is if there is an FA and it is represented by, oh, this is number four. If you have an FA and it is FA1, it represents a regular language and it is represented by R1. If you take the clean star of this FA, it will be R1 star. And even after taking the clean star, the resultant thing will still remain the regular expression, and the resultant language will be whatever the scope of this language, how big it will be infinite or whatever, but it will still be a regular language. Okay, its behavior, it will not, its scope will not change. It will never become any other category of language like non-regular language or context-free language. It will still remain a regular language. Okay, so that's the idea behind that. So these are the four steps, and now our remaining lecture will be based on these four steps. We will elaborate, we will see examples. I will ask you these kind of questions in exam, which will be coming in the coming slides. um, Now it is very important that you should able to find the differentiation between R1 plus R2, R1 dot R2, and R1 star. Okay, so hopefully, so you guys listening me, huh? So my voice is coming good. Yes, Lion, do you hear me?
We hear you.
I can hear you, Professor.
Okay, that's great. I was so silent, so that I was surprised that nobody is listening or what my voice is not coming. Anyways, if you are listening me and it is good, no questions, so then I'm very happy. Because normally people have so many questions in this, they don't understand in one shot. This is a little bit hard concept for students sometimes. Okay, so very nice. So now let's see whatever I just explained that and whatever you just see in these four steps, this is a repetition of that. It is not something different. It is 100% same thing in a more formal language. You see, uh, the lambda R1 and R2 is represented by also is also represented by this way, star, or if you put the parentheses around that, and there is no other rule then. So how you write the regular expression? This is the recursive definition of regular expression, and exactly what the more formal English than the previous one in form of recursive definition, and that's it. So here now, um, I explained last time also, but again, it's better I again write it here that if you have a regular language, it must have if the language which you are talking is a regular language, it must be represented by a regular expression, and there must be one FA for that, and there must be one TG for that, and all this is for regular language. Okay, so it's not possible that it is a regular language and it is missing any one of this. They are equal to each other. Now, if you have this regular expression and you want to prove that this is a regular expression by the previous recursive definition of regular expression, how we will do this? Uh, you pick one letter A by rule one. Every letter in summation is part of the regular expression, and lambda is also a regular expression. So you pick A, this is a regular expression, then you pick B, it is a regular expression, and then you pick A, this is a regular expression, B, this is a regular expression, and then you are saying that by rule 2, rule 3, R1 plus R2, so is a regular, so this is A plus B, this is a regular expression, this is a regular expression, and then if you see rule number 5, you can put the parentheses around that. So we put the parentheses around that. Okay, this is a regular expression. And then by rule 4, If you put the star, it will still remain a regular expression. So we put star here. And then again, you take letter A, letter B, A plus B, and then put the parentheses around that, and then the star, and then the job is done. This is your whole thing you prove by the previous rules which you define. And you can, if you have a regular expression by using these recursive rules, you can prove any regular expression that this is a regular expression by those recursive definition. It's not hard. You are very much expert now. You already did one assignment of this, and so there was a delay in your selection of TA. So we have your TA. I will add that his name is Devin Ryan. So he will be grade. He will be basically the person who will grade your assignment. So hopefully this week he will grade your assignment one. Now we are saying that let's see more elaboration of these rules. Lambda and its the letters in summation. There is an FA that accepts any particular letter in summation. There is an FA that accepts only the word lambda. So now look at this one. So it is a start state and the final state. So it will only accept one letter X to reach to the final state. Any other letter garbage collection, it is going here. Look at this. So all this is going here. This is a valid FA, but it's a kind of very abstract FA. So which will say that any word or any letter can come here. So and then if you wanna create an FA which will just accept lambda, I already told you if your start state is a final state, it must accept lambda. Look at this one. So your start state is a final state, it is accepting lambda. And then you are saying anything else goes here and this thing. So it is you are taking garbage collection. This is a valid FA, which will just accept the lambda here. That's it. Okay, this is very easy, huh? No, it's not hard. It's very easy simple question. So now rule two. So this is something which we are interested and we will see one example for this in very much detail and I will solve that example here in on the slides. So if there is an FA, this is basically a rule two, this one, which I just explained to you, that FA1 and FA2, and you can concatenate R1 plus R2, and this will be basically union of two FA. So this is basically now we are saying the same thing, and now we want to see the proof of that. Okay, so look at this one, FA1. If you have an FA and it is represented by FA1, and it is represented by regular expression 1, and then there is another FA and it is represented by FA2 and it is represented by a regular expression 2. So then there is an FA which we call FA3 and it is represented by R1 plus R2. So this is basically union of two regular languages. Okay, this is union of two regular languages. And now we want to see this by proof. We will see two FAs and we will do some process, some algorithm, and we will combine them, and then we will create a new FA, and then we will see that whether this is the same thing or not. Okay. Now, uh, this is I will come to this slide after um, explaining this example. So then you will be understand that what's going on. Okay. Let me keep it. Let me discard um, delete uh, this information here. And I can rewrite these things. Okay. So yeah. Let me add some more slides here actually after this. New slide, new slide, new slide. Okay, now I think we are good. So let me run this now. So we are saying that we have two FAs. Okay. So now the first, so this is the algorithm to prove that R1 plus R2, how we find this thing. Okay. So how I will ask you this question in exam, I will give you two FA like this. I will give you one FA and I will give you second FA. And I will ask you, can you please perform this operation R1 plus R2? Okay. So then you need to perform this operation and you need to show me your work, the whole thing, how you did this, all the tables, everything, and then that will be done that way. So now it says that if you want to create that, find R1 plus R2, and you have two FAs. So then your first FA, give the name of each state by numbering X. So we have this FA1, and this is represented by R1. So we give this FA x1, x2, x3. Already start and final state is there. We just put the x1, x2, x3. So this way we will know that this is x1, x2, and x3. This is a state, this is state, this is another state, this is another state. And if you have another FA, which is like this, FA2, and it is represented by regular expression 2. So name all of these states different from the first FA. It will be Y1, Y2, Y3, Y4. Okay. So just to show that these are two different states, belongs to two different FAs. Once you done that, and it is exactly what is written here, FA1. So change all of states, label all the states with x1, x2, x3. So start state will be x1, FA2. So change all the states with y1, y2, y3, and start state is y1. So plus and final states will be there, and the transition will remain same. Okay. So now our job is to combine these two machines and create a new machine which will be equal to R1 plus R2. This is our job. And create a new FA which will be FA3. This is what we want to do. Uh, so how we do that? So in this case, uh, when you have a new machine, so this new machine will accept any word. Either this word belong to this machine or this word belong to this machine. Okay. So now when you have one machine which has these words, either it will be belong to the first machine and will belong to second machine. So let's say we have a word which is A B B. So now when you have this word and when you start this word reading first letter A on the new machine FA3, you have no idea that this word belong to R1 or this word belong to R2, because the new machine FA3, it will accept both words either from R1 or R2. So when you have a new word which you want to pass to this machine, you will have no idea that this word belong to R1 or R2 until you reach to the whole word, and then you will be able to understand this word belong to either machine 1 or machine 2. And if it belong to machine 1 or if it belongs to machine 2, FA3, which will be a new machine, it will say yes, it is valid. If it does not belong to any one of this, FA3 will say it is not valid. This is basically what we want to do. So now what we will say, so we will say that uh, I just want to get on these lines. Alright. So we want to say that, okay, we want to create two tables now. Okay. So and we will create these tables in parallel. Okay. The first table. So we will say that the start state of new machine FA3, it will be, so the way we will assign the name of the states to this FA1 is all X, FA2 with all Y. The new machine which we will create FA3, it's all states we will assign the new name to Z. So this way we will know when you are dealing with any state which is X, it is machine 1. When you are dealing with any state which is Y, it is machine 2. And when you are dealing with any state with name Z, it will be a new machine FA3. So we are saying we will create a new machine which will be Z1. Okay, and this Z1 is basically, what is this Z1? This is the start state of both machine, because we have no idea the new word which we are trying to figure out is that is a valid or invalid, whether it belongs to R1 or R2. So we will say the start state of this machine and the start state of this machine. And you know that FA have a restriction. It has only one start state, so we will not confuse. So the start state of machine 1 and start state of machine 2, this will be the start state of your new machine Z3 Z machine. So we are saying X1 Y1 is the the start state of your new machine. Okay, so now this is basically what we are doing. So that X1 Y1 is start state of my new machine Z1. Okay, so now this is a process which you start, and you always start from the start state. So you are saying I have this new machine and its state Z1, and Z1 is equal to X1 Y1. What is that? Which is the start state uh, uh, of my machine X1 and machine 1 and machine 2. Okay, so now because Z1 is a final, so now if you see that this is a start state, so we will say this is also a start state. Okay, and now how we will choose that this new machine, this new state Z1, it is a final or not. If any state of machine 1 which is R1 and machine 2 which is R2, any state either X or Y is final, this new state will be a final. So now we need to see that whether X1 is final or Y1 is final or both are final, any condition, if it meet, Z1 will be final. And now if you go here, you will see X1, this is just a start state. Y1, it is a final state also. So this shows us that our Z1 is also a final state. Okay, so now, so you need to this is the first step you need to do on this table, and then you need to fill the second table with that. We will get some information from the first table, and first table told us that Z1 is the start and the final state. Okay, and then first table also tell us. So now we want to see that what happen if you are at Z1 and you receive A as input, and what happen if you are at Z1 and you receive B as input. What is A and B? This is basically your summation. Summation is equal to A comma B. Okay, so now if you are at X1 and you receive, if you are at Z1 which is X1 and Y1 and you receive A as input, what will happen? So you are at X1 and you receive A as input, you go to state number 2, X2. And you are at Y1, you receive A as input, you go to Y3. Yes. So we will say that if we have at Z1, which is X1, Y1, and we receive A as input, we will go to either X2 or Y3. Okay. Now, if you in this table, uh, you do not have this state or this combination before. You only have one combination x1, y1. So we will assign this new combination a new name, Z2. And we will say, okay, this is Z2. And based on this Z2, now, so I check the first state Z1 for A and B. So now I can say here, when you are at in table 2, this is table 1, this is table 2. So in table 2 now, I can say that when you are at state Z1 and you receive A as input, you will go to Z2. Yes, because if you see that this is what you did. And now you want to see that what happened if you are at Z1 and you receive B as input. Okay, so now we can say that if you are at Z1, which is X1, Y1, and you receive B as input, what happened? If you are at X1, you will stay here. If you are at Y1, okay, sorry, I missed one thing. So now you need to see that whether this X2 or Y3, any one of this is or both are final or not. So let's check X. So this one, any one is final or not. So X2 is not final, Y3 is not final. This will say that Z2 is also not any final state or something. It will be a normal state. Okay, so we will always check that. Okay, so now again go back to x1, y1 and see what happen if you receive B as input. If you receive B as input and you are at state x1, you will stay at x1. And if you are at y1, you receive B as input, you will go to y2. Okay, and which is x1 and y2. This is a new combination. If you receive B as input, which is x1 and y2. So we write this here. Okay, so we write this here x1, y2, and now if you see there, we do not have this combination before. So we will say this is z3. Okay, and so this way, when you have this z3 and so now so we can say that when you are at z1 and you receive B as input, you go to z3. Okay, and once you've done that, you put some flag for your clarity, for your information, that you check state Z1 for all possible inputs A and B. And now we repeat this process until we have a new state in table 1. And you can see that we have state Z2 and Z3. We will repeat this process of considering that particular state and what happen if you have A as input, what happen if you have B as input, and this way you can continue and fill both tables. And you can do this process until you are not able to find any new state in table 1 that will end this process. Okay, and now and what end of the day what happened, you will generate a new table which is table 2, and this will be for the new FA, which is a combined effect of R1 plus R2, and we will do this by this way. Okay, so now we will see. So far, any question, guys, here? Do you understand how we start this process and how we proceed? So Nikhil, do you happy with this?
Yeah, I'm pretty happy with it.
Okay. So Quinton, do you understand what's going on?
I think so.
Okay. Riley, are we good? Riley, Kaifer, are we good? Ryan, are we good?
All good.
Oh, okay, okay, no problem, Riley. So please, but this is very important, Riley. You need to see this. I will ask you this kind of question in exam. Okay.
I
So
just had a question, Professor.
yes.
Um, so on the right table, when determining, I guess what next steps for each FA, do we just does the order really? I guess the order doesn't really matter, and like what pairs we pick per
Uh,
se.
no, I mean
Or,
x1, y1 or y1, x1 in this way. Oh, no, order does not matter. Either you consider A first or B first, it does not matter.
Okay, I see.
I mean, is this your question? Yes?
Yes. Mhm.
Yeah. So like if I start in this way, that what happen if you are at Z1 and you receive A as input, so then I got X2, Y3. So yeah, you can consider initially what is B, what A, well, let's say I start instead of writing this way, I put B here and B here and A here. So I swap this and I consider first B and then A. Only difference will be in Z2 will be Z3 will become Z2 and Z2 will become Z3. But when you draw the new machine, so this table will not change. The table 2 will not change, this one. It will remain same, whatever the order you follow here. So end of the day, when you draw the diagram, it will be same. It will not have any impact on the diagram. Okay, so we did this, and then when you do this, I will go. I will not solve all the whole thing. I will go few steps, and then you can understand, and then you can solve this by yourself. Okay. So then I said, okay, let's consider this Z2, and what is Z2? X2, Y3. And if you receive A as input, so what happened? So you are at X2 and Y3. X You are at X2 and Y3, and let's see the previous these X1, Y2. So X1 was not the X1 is just a start state, and Y2 was also the start state. So Z3 is also normal state. Okay. So now X2, Y3, we are at Z2. So this one, if you are at X2, you receive A, you go to X3. If you are at Y3 and you receive A, you go to Y1. You reach to the final state. Okay. So it is basically X3 and Y1. We need to see that, do we have this combination before? No. So we will assign this a new name. Okay. So, and we write here Z2. If you receive A as input, you go to Z4. Okay. And now check Z2 for B, X2, Y3. So you are at X2, you receive B, you go to X1. You are at Y3, you receive B, you go to Y4, which is X1, Y4. Okay, so before we move to the next step. I always forget to find the final state. So X3, Y1. So this one. So you see that X3 is final and Y1 is final. So both are final. So it means Z4 is final. Okay, so Z4 is final because X3 or condition is any one is final. Z will be final. Either X is final or Y is final. But in this case, both are final. So Z will be final. Okay. Uh, so we are checking Z2 for B, and you are at X2 and you receive B, you go to X1. You are at Y3, you receive B, you go to Y4, which is X1, Y4. Do we have this combination before? No. So this is your Z5. Is any one of this is a final state? X1 is final? No. Y4 is final? No. So it means Z5 is a normal state. And we write that Z2, if you receive B as input, you go to Z5. We write this way. And we continue this process. Now we check this for A and B. So now we will go to Z3 and we will check that. So Z3, so we write Z3 here and we check that. What is Z3? Z3 is X1, Y2. Okay. So I put it here, the mark X1 and Y2. Okay. So this way we will not do any mistake. So if you are at X1 and you receive A as input, you go to here. And you are at Y2, you receive A as input, you go to here, which is X2, Y4. Do we have this combination before? No. This is Z6. Anyone is final, X2 or Y4 is final, X2 is not final, Y4 is not final. So it is non-final state, and Z3 in case of A go to Z6. We just write this. Okay. Now we will see Z3 for B. So what is Z3? X1, Y2. We will see this for B. So if you are at X1, you receive B, you stay here. You are at Y2, you receive B, you go to Y1, which is X1, Y1. Do we have this combination before? Yes. If you see the Z1, this is X1, Y1. If you have this combination before, you already assign a name. You do not assign this combination a new name. You can use the previous name, and you can say that in case of Z3, when you have B as input, you will go back to Z1. Okay, and we will not assign this combination a new name, and we check this Z3 for A and B. And now we continue this process for Z4, Z5, Z6, and if there is some states here, so you can keep writing that, and you can keep writing here until you find all those states, and you can do this process. Okay, so now if that is the case, how it will look like? It will look like something like this. You will end with the 12 states. In this table, it is the same thing. If you see, let me show you. Z1 is X1, Y1. Z1 is X1, Y1, and look at this. Z1 is final and start. Z2 is X2, Y3, Y3. Z2 is X2, Y3. Z3, Z4. Z4 is final. Look at this. Z4 is final. And then Z5, Z6, and we didn't go to Z3, Z7, otherwise it will be final. So I draw this table here, and then we combine, we feel, look at this one. Once you finish the all, you do not find any new state here, so this process will stop. Okay, and now what happened? Look at this. This is a new table, and this is a Z table, and this Z table will tell you what is the start state, how many states are the final, and how each state combine with other state. This is a transition table. If you have a transition table, you can easily draw the FA from this transition table. Now you just need to draw the table. So you are saying just partially I like to draw here. Z1 is a state, start and final. Z2 is another state. Z3 is another state. Z1, if you have A as input, go to Z2. Z1, if you have B as input, go to Z3, and Z2, then you go to the next and combine this and introduce the states, and you start doing this, and you will get something like this. It's a very complicated, it's a very big machine, so we just try to organize in a very nice way so it will be less complicated and look beautiful. But it does not matter. You can draw this as you like. Okay, and now this is a new machine which will be R1 plus R2. It is combination of these two machines, this machine and this machine. It is this one machine is doing the combined job of these two machines. So this new machine is basically accepting, is a union of these two regular languages. It can accept all words from regular expression 1 and all words from regular expression 2. So this is basically a new machine. And you need to, and this way you find the union here. And I think that we done this with this. Any question in how we find R1 plus R2? Only complicated thing is you need to understand what will be the start state. This is very important, and how we proceed to the next step, and that's it. So this way you can figure out how we can do this. Okay, if you are able to do that, so then job is very easy. It's not hard. Okay, so any if you guys have any question, someone is writing something. Okay. So now this is another example, and this is another FA. This is another FA. It is that this is a transition table of this FA. This is transition table of this FA. You need to combine these two machines. you need to perform that process. You need to create two tables, and one is A and B, and both tables should fill parallel. And then once you do that, and you get this table, which is Z table, and this table will tell you how to draw this new machine here. So you can draw this new machine. I mean, I just draw one time the whole lengthy process, and then I just pick the diagrams to show you that what we want to say here. Okay, this is the same thing. And then, so here we done one rule and it is good. And now if you have no question here, uh, then we go to the another rule, which is where it says that I explained this already. This rule number 3. Look at this one. FA1 is R1, FA2 is R2, R1 dot R2. It is combined effect of a new machine, which is FA3. But here order matters. It will only accept those words which are accepted by R1, which starts from R1 and end with R2. So now this, I told you that R1 dot R2 is not equal to R2 dot R1, because here you are saying new machine will start from R1, end with R2. In this case, you are saying new machine start with R2, end with R1. So whereas in case of R1 plus R2, order does not matter. The both thing have a same meaning. It is same. Okay. So now we covered this. Now we are doing this thing. Okay. Let me see how we draw this. Uh, draw this basically. This is basically you will get some effect of like this. If you have a machine, this is your R1 and this is your R2. So you basically want to say that I want to combine these two machines. That the new machine which you want to create should be like this way. So it should be the final state of this, and it is connected with the start state of the second machine, and then this will be whole thing will be a one machine which will accept, which will so and then we delete this start state, and then it will start, and then we delete this final state. So it starts from here and end with here. So you see, so this thing is your one machine, and this is your second machine. And now what happened? The new machine is basically it accept a word which start from the machine one and end with the machine two. This is basically this something like this kind of behavior we want to achieve by this process. Okay, this is basically what we want to say. Now, let's say we have these two FAs here, which is, so let me add a, uh new slide so you will be able to understand the way I did before. So, okay. So now we have these two FAs and we are interested to find R1 dot R2. I don't know why this happened. R1 dot R2. So we are saying this is your R1, this is your R2. So you should be very much clear that what is R1, what is R2, because if you do mistake here in figuring out which one is R1, it means that the new machine will depend on this, because you are finding R1 dot R2. So if you change the order, if you consider this as other R1 and this as R2, so this will change the machine. Okay, so it means that now you are starting from R1 and ending with R2. This is basically what we want to do. So the process is same. You need to create two. Same thing, A comma B. This is table 1. This is table 2. Okay. I mean A or B. So now, if you remember, when we consider this previous machine, we said that the start state will be anything because we don't know. It will accept a new word which will be either accepted by this machine or accepted by this machine. So start state can be anything, either x1 or y1. But in this new machine, we know that thus always we start from R1 and we end with R2. So now when we talk about the start state, we will never consider the start state of both machines because we will not start from machine 2. We always start from machine 1. Okay, so we are saying what is so again label all the machine 1 with x states, all the machine 2 with y states, and the new machine will be z machine. Okay, so we are saying the start state, which is z1, will be x1 of this machine, x1. Okay, now we do the same job. We will consider a. So what is x1? X1 is a start state, so z1 will be a start state. Okay, so now we are saying that uh, we will see that now what happen if you are at the start state and you receive a as input and b as input. You are at x1 and you receive a as input. It will take you to x2. We do not have this state before. We will say this is z2. And what is x2? X2 is a normal state. It's not a final state or something. So we will say this is a normal state. So in case of z1, when you have a as input, you go to z2. Okay. So now we will check z1 for b. If you are at x1 and you receive b, you will stay at x1. Look at this. Okay. So it means that if you will be, in case of b, you will be at x1. So we already have x1 before and we give this combination a name z1. So we will say in case of z1, if you receive b as input, you will stay there, z1. Okay, and x1 is a start. We only consider one time start state. We do not give this state a new name. So we just keep it as it is. The same process until you have the state here. You continue this process. Now we check this state for a and b. Now we consider the second state z2 for a and b, and z2 is what? X2. So we are saying that if you are at x2 and you receive a as input, where you go? You go to x3. Okay. Now here is a trick here. I have a question with you. If I combine these two machines, let's say this is a previous machine, and I am here and I receive B as input here, and I combine this machine here also. How you know my word is something like this: A, B, 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 something like this. I start from here, A, I go here, B, I come here. I have third B. So now third B might be this, or it might be this. Yes, because you combine this plus sign with this state. This is what you're saying. So you have no idea that this third B belongs to this B or this B, because we have both here B's here. So now it is ambiguity. You are not sure that either if you have this word, where your first part of the word finish, either the first machine, because these are, if you see, these are two machines. So how you know that this my word finish here and this belongs to machine 1 and this belongs to machine 2, or my word finish here and this belong to machine 1 and this belong to machine 2, or my word finish here? So you have no idea, because you have loop here on B, you have loop here on B. It can be as many B's here, it can be as many B's here, and you have no idea that at how you do this factor, that here your first part of the machine finish and now you need to jump to the second machine. So in this case, because of this ambiguity, what happen whenever you encounter the final state of first machine, and you may have more than one final state. Whichever final state of first machine, when you encounter that, you might consider, you must consider, might be you are at this time staying here, or might be you move to the next machine. So you need to consider both options. So it, what does it mean? I mean to say, you, whenever you consider the, whenever you touch the final state of first machine, you must consider the start state of the next machine also, which is y1 here. So now if you see this, x3 is the final state of the first machine, and whenever you encounter x3, with x3 you always write y1, because you don't know that you stop here or you move to this machine. Okay, so when we encounter the start state of the first machine, we final state of the first machine, you must consider the start state of the next machine. Okay, so that's the idea behind that. And now if you see this x3 y1, you do not have this combination before, and uh, and and then you will say this is z3. Now, is this a final state? Z3 is a final state or not? X3 is final. And according to our previous study, what we did for the R1 plus R2, this should be final. Z3 will be final. But here now, we are not doing R1 plus R2. We are doing R1 dot R2. What does it mean? Word start from here and finish here. So it means whenever you encounter the final state of this machine, this will not decide the fate of Z machine, that it is final or not. Whenever you encounter, you touch the final state of R2, then you will say this will be the final state of Z machine. So here, whenever you have Y2, then you will say that Z will be a final. So this is X3 final, only have one impact. You need to write the start state of the next machine, which we already done that. But Y1 is not final. Regardless, x3 is final, so z3 will not be final. Z3 will be a normal state. Okay, so you, but you write here in case of a as input, you reach to z3, and that's it. I hope that it is not complex and you understand this. Okay, so now what we are saying, that you check x2 for b. What is x2 is, and we need to check this for b. If you have x2 and you got b, you go to x1. Okay, so we write x1 here. We do not assign this a new name. We already have this name, which is z1, and we write that, and we consider this x2 as a and b. X1 we already did that, so now we can take that new state z3, and we will check that for a and b. So what is z3? X3 y1. So now you are saying that I need to see this for a and b. So x3 is, so x3 y1. So what does it mean? You are here and you are here. Okay, so x3, if you have a, you will stay at x3. Okay, so what is that? It is x3. And x3 is what? A final state. You need to consider the start state of the next machine. And now we check this x3 for a. Now you check the second part of this z3 y1 for a. If you are at y1 and you receive a, you will stay at y1. So you write y1 again, because x3 y1 you get from this thing, and y1 you get from this thing. We do not write the duplicate terms. Initially we write it, but once we see that these are duplicate terms, we just keep one term. Okay, and x3 y1, do we have this combination before? Yes, we have this. Order does not matter here also, like y1 x3 or x3 y1, it is the same thing. So we will say that, okay, yes, we have that, and this is basically your z3. So you write z3 here. You do not assign this a new name. Okay, so we check z3 for a, and now we check z3 for b. So x3, if you have at x, if you are at x3, you receive b, you will stay at x3, which is x3 and y1, because it is final. And if you are at y1, you receive b, you go to y2, which is final state. So now x3 y1 y2. Do we have this combination before? No, this will be Z4. And what is Z4? Is this a final state? We need to see that the Y state machine has any final state here or not. Yes, Y2 is there and which is final. This will decide that Z4 is final. We write Z4 here. Okay, and then you keep continue this and check for all the, so you need to check x3 for a and b, y3 for a and b, y2 for a and b, and this will decide. So this way you can continue this. uh, I check these states for a and b. Now the next thing will be z4, and once you do that you will get something like this. Okay, and from this you will get this table, and from this you draw this machine here, you can see that. Okay, and once you draw this machine, so this will decide that how this machine will look like, and this will be basically r1 dot r2 here. And now look at this one. If you find r2 r1, it will be completely reverse. So this machine, this part will come here and this part will go here. So it will be completely reverse. It is not same machine, it will be completely reverse machine. So that's why r1 dot r2 is not equal to r2 dot r1. Okay, so the only trick is how you find the final states of this machine in this process, how you choose what is the start state. That's a difference. Process is same. Okay, so process is same. So now if you see these tables, I can so you can understand that what is the difference between r2, r1 and r3, these two machines. And if you do this, follow this table, and you draw these things, you will get something like this, which is R1, R2. And just for your understanding, that how I proceed. So whatever I talk here, I try to write the commentary of this also here. You can read this also. This is the explanation what I just when I explaining to you what I just talk. So I try to write it here also, so you will not lost that how I draw these two tables. So this page. So it is the summary of what I was just talking about and how I draw these two tables. When you read this, you will also get the same thing if you lost that what we how we draw those two tables. But this is now recording, so you can even listen me also. And this is the summary of that concatenation, what I just explained to you in more good English. Okay. So, and this is another example. You can do this at home. And I didn't draw table here, but once you draw that, you will get this effect. Here I want to show you that if you have these two machines, if you find R1 plus R2, look at this. The resultant thing will be this. But if you find R2 dot R1, look at this. It is completely different machine. It is not equal to this machine. Yes, so this is what I want to say. But if we are interested to find r1 plus r2 or r2 plus r1, both machines will be same. There is no difference. Both machines will be same. But in this case, you see, both machines are different. They are not same. This is what we want to say here. So are we good? Any questions so far? Otherwise, I mean, I'm keep going. So we have this thing, and then what left after this? We have more stuff. Okay. Yeah. So guys, any questions so far?
Can we do another example of the whole table process?
Example of?
Yeah, the process of using the tables.
Uh,
I don't know. I feel like I don't understand what the so the table on the right is the states for the machine you're creating.
on the right, yes. Table because you need to. Our interest is to find this table. Oh, sorry. To draw this table. Yes. Uh, but we cannot get this until you draw this table. So this is table one, and this is table two, and you need to fill both tables parallel the way I did here.
Okay.
I mean, this is the detailed version of this thing. So this is the same thing, but what I did not write the duplicate terms here. I just did this in my just because less space. I want it clean, so I write this way. But actually, I want you to do in exam. Show me whole work. So if you like, if no name, so keep it there. This way, I know that you are doing this. But I mean, if you do not write this, let's say x1 in this, because it is the same thing, so it does not have impact on the new machine, but uh, it is good to show the work. But do you understand how we create table 1 and how we from table 1 how we create table 2?
I'm not sure.
Okay, where you lost?
Uh, I guess I
Okay,
understand the point of the tables. I don't really know what you're doing to fill them in.
okay, so let me revise this. Yes, so now uh, we start from z1. Why do you understand why we write only x1 here, why we did not write y1 with that?
Which what is this representing? Which
So this one.
okay.
So now I will revise this, and you will tell me if it makes sense to you. Okay. So now I am so this is our table, both machines here, and
What slide is that supposed to be on? Because the numbers are different.
uh, this is this. Oh yeah. This is the slide number. So far this slide says 41 here, but I mean this is not the correct number. What I believe. Do you see my screen?
Yeah, I'm just trying to find it in my slide so I can see it when you're on the table screen. It's kind of hard to follow with it being on when you go between them.
Okay. So so find your slides. So I open this screen here.
Okay, yeah, it's slide 33.
Okay. I will correct the numbering. So now we are saying that if you are here and I am interested to find R1 dot R2. Okay. So now what I'm saying, I need to draw two table. I draw one table, I draw second table. And one table is so we need to fill these tables parallel. Okay. Here now we are interested to find R1 dot R2. So we know that we always start from R1 and we always end with R2. That is the reason when we consider the start state of the Z machine, we always consider the start state of the R1, whatever the R1. So R1 is X1 here. This is my R1 and this is my R2. I consider this. So now I will say X1 is my start state and which is Z1 and start state here. That's what I did here. If you see Z1 and X1. Okay. And now I'm saying that, so this part you understand.
Yeah.
Okay. Now I need to see this Z1. I fill both tables parallel. And now I need to see what happen if you are at X1 and you receive A as input. So you tell me now, if you are at X1 and you receive A as input, what happened?
Goes to X2.
X2, perfect. So you go to X2. We do not have this state before. We will assign this state a new name, which is Z2. Does X2 is a final state or start state? No, it is simple X2. We write Z2 here. Here till here we are good, yes?
Yeah.
Very nice. Now I will see X1 for B. if you are at x1, you receive b as input, you will stay there at x1. You see there is a loop here. So I said x1. We already have the name given to this x1, which is z1. I do not assign the new name, and I will just write z1 here. So this is what we did with x1. We check this for a and b. And we continue this process until we have the new state here. We have new state z2. So now we are saying if you are at z2, so far we are good, yes?
You did. Okay. Yeah, I get it.
Very nice. So please let me know when, don't let me go to the next step if you confuse at any stage. Okay, so I'm repeating this. So now I consider x2, which is z2, and check what happen if you receive a as input or if you receive b as input. Now in case of x2, if you receive a as input, what happen? You go to where?
X3.
X3. And what is x3?
A new.
A new state. But is it this is a final state? Yes.
Oh yeah.
Okay. How you know that your next letter belongs to, and let's say uh, you have if you have a word which is A, B, B, B. Okay. So now this A will take you to here, and then you have a B, let's say this B, and this B is here. Yes. Do you understand this, what I'm saying? You
Yeah.
have A, it will be here. You have B, it will be here. You have then B, it will be here. So, then A, then it will be here, let's say. And then B, it will be this. Okay. Now you have this B. This might be B will be here again, or this B will be uh, this B will take you to let's say this state also. You have no idea, or then you have A here, let's say. Okay, not sorry, not B. So this A will be might be this A because you have a loop here A, or this A will be this A. You have no idea that you are at this state or you are in the next machine. So if whenever this is the reason that whenever you encounter the final state of first machine, you always consider the start state of the next machine. So whenever you encounter x3, we will say might be we are at x3 or might be we are at y1. Does it make sense?
Yeah, that makes sense.
Okay. So now we do not have this combination before. We will assign this a new combination, new name Z3. So we did this. Now we need to see that whether Z3 is a final state or not. So X3 is final, Y1 is not final. If this will be the previous machine, Z3 will be final. Because previously we said that whenever you encounter any one is final, the new state will be final. But here now we are not finding R1 plus R2. We are saying our word start from R1 and finish at R2. Our word will never finish at R1. So if we consider Z3 as a final, what we are saying, our word can finish here, new word. Yes. So we will not do this. Whenever you encounter the final of the next machine, that will decide that this Z will be a final or not. We do not have Y2 here. So the first machine final will not decide that Z is final or not. The second machine final will decide that this is a final or not. Okay. So now because there is no Y2, so this is simple Z3. So when you encounter, so now that's good. So now do you understand this? How we write Z3 and X3 Y1?
Yeah.
Okay, so now check x2 for A. If you x2 for A, very good. So now what is x3?
Final state.
X3 is the final state of the first machine, yes?
Yeah.
And what is the rule? Whenever you encounter the final state of the first machine, in
You have to
case of R1 dot R2, you always consider the start state of the next machine, yes?
Yes.
So we write y1 with that. And we check this only for x3. Now we check what happen if you are at y1, this part, and you receive a as input. So what happen if you are at y1 and you receive a as input?
You go to the same state.
Same state y1. So we write this here, but we do not write the duplicate terms. So we just first we write, then we cross it, and we will see x3 y1. Do we have this combination before? Yes, we have this combination before, which is z3. So we are saying that in case of a, when you are at z3, you will stay there at z3, and we check this for a. Now we check this for b. So first we check for x3 for b. So what happened? Z3. So now you are checking Z3 for B. Yes, we are here and we are checking this for B. And Z3, first part is X3. So what happened if you are at X3 and you get B as input?
Same state.
Same state, which is X3. And X3 is what? A final state. Whenever you encounter the final state of the first machine, you need to write the start state of the next machine. Yes, we did this. So now we are saying, what happen if you are at y1, this part, and you receive b as input? What happen?
Goes to y2.
Y2. And what is y2?
New
New state, but this is the final state of the
final.
second machine, not the first machine, the second machine. Yes.
Yeah.
So now, if you encounter the second final state of the second machine, that will decide that your this Z, and you do not have this combination before, we will say this is Z4, and now Z4 has Y2, which is the final state of the second machine. This will say that Z4 is a final. And we write Z4 here. Make sense?
Couldn't it for if it uses B, couldn't it also stay at the same state because x3 is going to the same state?
Yeah, when you have B as input and at the first machine you receive B as input, you will stay here x3. You see, I write x3, and then because this is final, you consider the y1 also. I write y1, and then I need to check this y1 for B. I check this y1 for B. It goes to y2, and I write y2 here. x3, y1, y2.
So wouldn't B be able to go to both Z3 and Z4? Like, isn't that, or are we splitting? Does X, so in the first machine, the final state, it's kind of like being just like overlaid with the start state of the second machine, right?
Yeah, in first machine you are finding the union machine. In this machine, so now I give you idea. You are working, you have one machine in one room, and you have another machine in another room, and you have five people working on the first machine and five people working on the another machine. Let's say it's a auto industry, and you are saying, is it possible that I have 5, 10 people working on two machines, five in one room, five in another room, and they both machines are creating two different products. One machine is creating uh, uh, something else, other machine is creating something else. Is it possible that I reduce my labor and I combine both machines, and it can produce both things? Whatever input I give, it can produce both things, but I will use just 5 people which will work on one machine. So now two different products which you are creating by two different machines, now you create a one machine which has ability to produce two different products, which you before got by two different machines. Now you get the both products by this machine. Yes, this is R1 plus R2. Now you are saying this is the first scenario. The second scenario is you start your business and you are creating one product, and then you another person who has another business, he buy your product and use this product to create his product. Means he need your product first, and then he is able to make his product. He cannot make his product without getting the part from you. Okay, so now it means your part is mandatory and it should be first there, and then he is able to complete his product. So now order matters here. It is not possible that he cannot create his work, his product, before getting from the product from you. Yes, so now here order matters here. First you need to create, so you both are doing separate business. Then you think that why he is making more money, why not I create a new machine, and which will I will create my this first product, and then I use this product and into them in that machine, and I can generate that second product also, which depends on the first product. So now here order matters, but you combine both machines together, a new machine which first create first product and then use that and then create a second product. This is basically R1 dot R2. Here order matters. You cannot swap the order here. So this way we know that we always start from x1 and we always finish with y2. We always start with this machine and we always finish with this. This will be the final. Whenever you encounter y2, this will decide that z is final. And whenever, but in previous case, in previous machine, any one final will be the final. Either x1 is final, x is final, or y is final.
X3 kind of corresponds with hold on, let me think. Because I'm just thinking that if you're considering X3 and Y1 when you're considering what happens when you have B there, with X3 B goes back to itself, but with Y1 B goes to a different state.
Yes.
How come we just
Okay,
Y2?
okay, I have a question with you. If I connect this machine with this with lambda, okay? Are you listening here? Yes?
Yeah, I'm listening.
Okay. And do you see my screen?
Yeah, I see.
Okay. I connect this state with this lambda, and I have A as input, and I am at x3. I am x3. I have A as input. This input is on x3 or y1?
X3.
Okay, I disagree with you. Let's say I said it is at y1, because if you are at x3 without any in letter with lambda, you go to y1 and then you have a here.
Oh,
Make sense?
yeah.
Okay, now if I am x3, I again repeat my question. I receive a as input. This input is at x3 or y1?
It's at Y1. It's
I
at
disagree with you.
oh,
Let's say I have this a and I have a here. So you make, now you understand, you might have, I both if you just say x3 or if you just say y1, both time I disagree with you. But if you say might be it is at x3, might be it is at y1, yes, now I agree with you, because it is connected with lambda, and it x3 has the ability to process a, y1 has ability to process a, but and both are connected with lambda. And because we don't know that this a belongs to previous machine or the next machine, yes, so we don't want to do any mistake, so we will say x3 y1. We might be it is here or might be it is there.
okay.
Now you understand why we write y1.
Yeah,
Okay.
I understand.
Okay, so this is basically, if you see this, this is what we have here also. Look at this one. So you have lambda here. Implicitly, it has lambda. And if you are at this final state and you receive B as input, so this B belongs to this or this. We have no idea. Yes, it might be this one because it is also taking care of B. Look at this. It might be this one. It is also taking care of B. So then we will say that it might be this state or it might be this state. We will consider both states. Make sense?
Yeah, that makes sense.
Okay, that's great. So, so this is something what we did, and now if you see this, we can have this table, and from this table you generate this table, and from this table you draw this diagram, and the job is done. And this is the only difference between previous R1 plus R2 and R1 dot R2, how you choose the final state and how you choose the start state. Remaining process is same. You always consider A and B and this state, but how you choose this is different, and how you choose this sign, this is different. So it is because of this. Okay. So yeah, you see that it is very important that when you ask a question, it is not only for you, it is good for a lot of other people. So now, but just not you do not lost. I already write whatever I explain here also. So you see, you read here, and when you draw that, you don't. If you read these commentary here, which I write here, it will take you to successful generation of both tables. I write step by step what I'm doing, how I get Z1, how I get Z2, why I choose Z1 as a start state, why not I write a Y1 with that, why I choose Z4 as a final state, and how I get Y2, why we are writing Y1. So everything is written here. So I write that here, and this is a summary of the algorithm, and then this is another example. So you can do that. I just want to show you that if you in this case r1 dot r2 and r2 r1 are different, okay, and this is not same, it is different. So I mean, we don't want to hurry. I know this is fast semester, but this is something you need to understand because the coming chapters might be long but easy. This is a hard thing, and I will ask you this question in exam, this kind of question. So but not very long. I deliberately choose the long questions for the chapter. I will give you long questions for the assignment, but exam it will be not long, it will be short version of this one, uh, because assignment and in this, because I do not want to miss any scenario. That's why I have this long questions and long tables, so you can, when you draw that, so you can use that and you can understand that. Okay, so I think that we should not go to the next step, and we should stop here. Tomorrow we will, if you understand this thing, this will be very great, and tomorrow we will finish the remaining slides and one more concept, and then that after that it will be easy. But if you have any other question, please, you can ask me. I will be online right after this class at 11 o'clock in the office hour. You will see that link on the course name there with the start of the course where you have the office hours. The link is there also. You can join another meeting for that, for my office hour. I always stay in my office hour from 11 to 12 o'clock. So I always log in there and wait for you. So if you want to come, so you can come there. If you do not see me there, sometimes what happened that nobody comes, so meeting automatically cancel because of nobody show up there. So it is automatic process that no activity, it will cancel. So send me email right away. I will log in again. So I will get email if someone is there in the meeting room. Okay, so guys, thank you very much. Please do this, and then somewhere in the next week we will do the midterm exam. That will be online by using the Panopto. No, sorry, what is this? Another software name? What the exam name? Something.
You mean Proctorio?
Proctorio, yes, Proctorio. So we will do that, and then you will see that exam there the way we did the final exam in the previous semester. Okay, guys, thank you very much. Here I am stopping the this recording.